let's do an example of the chi-square goodness of fit test. If you haven't seen this test before, I would recommend going back and watching my first video on this topic. It will give a little more explanation about the actual statistic and the calculation and when we use it. This is just going to be an example of how we use it. So a kids' carnival has a spinner to award prizes. An observant student wonders if the spinner is truly fair. The spinner is spun 100 times and the results of those spins are below. So let's just notice really quickly on this spinner that we have amounts of 0 here and here. So there are 4 zeros. We have some ones. We have 3 ones. We have 2 $5 amounts, and then we have 1 $20 amounts. And here are the results of the actual spins. Now, this is the frequency. This is what really happened. But what we would have expected to have happen, based on our spinner, is that if there are 4 zeros out of the 10 spots, that 40% out of the 100 spins, or 40, would have been $0. So you can see we certainly had more people come away with 0 than we thought. Now, there were 3 $1 spots, so we would have thought we would have gotten 30 people that only won $1. There was 2 $5 spots. We would have thought we would have gotten 20 of those, and 1 $20. So all of these expected counts are just based on the proportions that should have happened. So, for example, 40% of the 100, so 0.4 times 100 is 40. 30% should have won $1, 0.3 times 100, 20%, 0.2 times 100, and then 10%, 1 out of the 10 spots. You'll notice really quickly that I have counts here. I don't do proportions, so I always convert. Everything should be comparing counts. The formula we have, the table we have, everything we have is based on the number of times something happens, not the proportion of times something happened. You would not want to convert this to be 50 out of 100 is 0.5, 30 out of... You don't want to do that. You want to compare the expected and actual counts. So, is there evidence at the 0.05 level that the spinner is not working properly? Well, I'm going to shrink this down for a second, and let's do this hypothesis test. This is the chi-square goodness of fit. Our null hypothesis is that the observed distribution of, in this case, winnings is equal to our expected distribution of winnings. I'm just going to use a little bit of simplifying the language here so I don't have to go too far up. And the alternative is simply that the observed distribution of winnings, you could also say like the spins or something like that, is not equal to what we expect. Okay, so that's our beginning, our kind of state. Our plan. Well, the first thing is that the number of spins should be less than or equal to 1/10 all spins. Now, maybe this carnival ride carnival thing was really popular and they spun a bunch of times without explicit language saying, no, it wasn't played that much. We're not going to fail this first condition. We're going to assume that it was spun more than 1,000 times. Remember, the other condition here is that all of our expected counts are bigger than 5. And they all were. In fact, I'm going to just write them down again real briefly. I'm going to say these were our expected counts. They were all greater than or equal to 5. On an AP exam or something, you'll definitely want to explicitly show your expected counts. You'll want to create a new table or something, but you don't want to just say the expected counts were bigger than 5 without showing that you actually did calculate those expected counts. Now, instead of using the formula, which just as a quick reminder, the chi-square formula is the sum of the observed minus the expected squared divided by the expected. I'm going to use the calculator. And before I bring up the calculator, a quick reminder of degrees of freedom. Degrees of freedom is not one less than the sample size. Rather, it's one less than the number of categories. We have 4 categories, 4 amounts. So our degrees of freedom will be 3. Let's open up the calculator. So the first thing we want to do is put our work in list 1 and 2. You'll notice in list 1 I have my observed values, and in list 2 I have my expected values. Then we're going to go to the stat menu, over to the tests. And we're going to go all the way down till we see chi-square goodness of fit. We'll choose that. Again, the observed were in list 1, the expected were in list 2, and because we had 4 categories, we had 3 degrees of freedom. I'm going to calculate. There's our chi-square statistic, and there's our p-value. So you can see 0.012. So in terms of our plan or our do piece of this, I'm going to say that the chi-square statistic with 3 degrees of freedom is 10.83, and our p-value is 0.013. Now, I'd said to do this at the 0.05 level, so our conclude on this would be that we reject the null. And the reason is the p-value is less than 0.05. What does that mean? We have evidence the spinner is not working properly. Again, if this was your first time seeing a chi-square goodness of fit test, I would urge you to go back to a video that I made talking about the actual calculation and why the statistic is what it is and how you could do it by hand. But if this video helped you, please like and subscribe for more math help.